Today we are working on our notes for section 5.5. This is day one, solving trigonometric equations. So for our first example, we want to find all solutions to the trigonometric equation cosine theta equals 1/2. So what we are looking to solve here is for theta. The way that I do this is I think about my unit circle. And I think which two quadrants is the cosine positive. Okay, and so I remember that the cosine is positive in quadrant 1 and quadrant 4. So I am going to cross out my quadrants 2 and 3. So then I want to think on my unit circle, I'm looking for my coordinate where the cosine, the x-coordinate is 1/2. Okay, I recognize this is square root of 3 over 2. You probably don't have to write it. And then in quadrant 4, I also have this angle 1/2 square root of 3 over 2. And I should have written this down. Okay, so I see that cosine theta equals 1/2 when theta is pi over 3, or when theta is 5 pi over 3. Okay, I also could have written this as negative pi over 3. For whatever reason, my convention is I usually do positive angles. But here's the thing. Are these the only times that cosine theta equals 1/2? And I think if you think about it, because cosine has a period of 2 pi, anytime we go around 2 pi units, we're going to be back at another angle. So we show that by saying at theta equals pi over 3 plus 2 pi n times, right? Where n is an integer. This is like the notation we used in the previous sections. Or 5 pi over 3 plus 2 pi n. Again, where n is an integer. Okay, so equivalently, we could have written this as theta equals pi over 3 minus 2 pi n. Okay, because think about it. If we're here and we go negative 2 pi n, we're back at that angle. Okay, or we could have written this as theta equals negative pi over 3 plus 2 pi n. Okay, and again, we need to define that n as an integer. Okay, and I talked about this, how the 5 pi over 3 is equal to negative pi over 3. Okay, if we went negative pi over 3 and then we went plus 2 pi n, would be back at that angle. Okay, so you can also do a plus or a minus for your 2 pi n. By convention, I usually use the positive, okay, but either are equivalent. So the big thing about our trig functions is generally for cosine and sine, we're going to have 2 places on the unit circle. Okay, more often than not, we're going to have 2 places. The quadrantial angles, sometimes we only have 1. Okay, but all the other parts in the unit circle, we're going to have 2 times. And if there's no restrictions on, which I'll show in the next example, but if there's no restrictions, your answer should always have something that shows the type of period, okay, that shows that there are infinitely many answers to this. Okay, our next example, we want to solve 2 times the sine of theta plus square root of 3 equals 0 This time we're on the interval 0 to 2 pi. So we're including 0 because there's a bracket, and we're not including 2 pi because there's a parenthesis. So the first thing that we're going to do here is we just want to solve this equation like it's a linear equation. We want to isolate the sine theta. So the first thing that I'm going to do is I'm going to subtract the square root of 3 from both sides. So then I would have 2 sine theta equals negative square root of 3. I'm going to divide both sides by 2. So I get sine theta equals negative square root of 3 over 2. Okay, so again, I go to my unit circle. I am thinking, where is my sine negative? It's not negative in the first quadrant. It's not negative in the second quadrant. So now I am looking for my two angle measures where my sine is negative square root of 3 over 2. Okay, and so I remember that as the points 1/2 negative square root of 3 over 2 and negative 1/2 negative square root of 3 over 2. Okay, so again, this corresponds to two angles. It corresponds to theta equals, this first angle is 4 pi over 3. And my second angle is 5 pi over 3. Okay, but because of this restriction between 0 and 2 pi, do I need to add my 2 pi n? Okay, if I add 2 pi n to this angle, I would be outside of my interval 0 to 2 pi. Okay, so for this, for example 2, my answers are just these two angles. Okay, but it's very important that you have both of them. You can't just have one. Okay, and like I said, the reason why we don't need to show anything to do with the period is because of this restriction from 0 to 2 pi. Okay, let's move on to example 3. So we are going to be talking about triggers when you have trigonometric equations and certain things that you can see that you need to remember to do certain things. Okay, having a coefficient other than 1 adds a step, and there's a difference between example 2 and example 3 because of this coefficient in the argument. Okay, but we start the same way. We want to make sure that we have our trig equation isolated. And here we do. We have the sine of an angle is equal to 1/2. Okay, so again, I go to my unit circle. I'm thinking, where is my sine positive? My sine is positive in quadrants 1 and 2, so I'm crossing out quadrants 3 and 4. Okay, this time though, I know that I have this point, which is square root of 3 over 2, 1/2, and this point over here, which is negative square root of 3 over 2, 1/2. Okay, so this time the angle measure that I'm putting in the argument, that 2 theta needs to be either pi over 6 or that 2 theta needs to be 5 pi over 6. Now, if this argument was just theta and we were looking between 0 and 2 pi, we would be done, okay? Because we would have found the two angles between 0 and 2 pi. But this argument of 2 changes it, okay? And what we need to do is we need to take into account the period and see, because the period is changing, if there are any other values between 0 and 2 pi. Okay, so I'm going to add 2 pi n here. Again, I'm using the 2 pi because the period of sine is 2 pi. And I'm going to add that to both of my values. And now I need to solve for theta. And to solve for theta, I need to divide every term by 2. Okay, so this becomes theta equals pi over 12 plus pi n. And this becomes theta equals 5 pi over 12 plus pi n. Okay, and again, our n is an element of the integers. So what we are going to do next is we are going to start making a list of these values so that we can find the solutions between 0 and 2 pi. So let's first let n equals 1. So theta equals, to save myself some of my mental math, I noticed that pi over 12 is in twelfths. So I'm going to change this pi to 12 pi over 12. Okay, that's still equivalent to 1 pi. But I have 1, if n is 1, this is going to be 12 pi over 12. Actually, first I should let n equal 0. So this becomes pi over 12. Then I should let n equal 1. So this would become 13 pi over 12. So I know that my bottom restriction is 0. My top restriction is 2 pi. I'm going to put that in terms of twelfths too to make this a little easier for me. So this becomes 24 pi over 12. That's equivalent to 2 pi. So now if n is 2, this is going to be 24 pi. If I add anything to it, I'm going to be outside of 24 pi. Okay, so this did become 25 pi over 12 when n is 2, but that's going to be outside of my domain, my restriction. Okay, so I'm going to cross out and I'm not going to look for any values bigger than that. Also, I can think if n is -1, okay, I can see that I'm going to get a value that's less than 0, so I don't have to worry about my negative values either. Okay, so for my next one, when n is 0, n is going to be 5 pi over 12. Okay, when n is 1, this is going to be 17 pi over 12. When n is 2, this would be 29 pi over 12. Okay, and the way that I'm getting these, remember, 2 times 12 would be 24. 24 plus 5 would be 29. Okay, 29 pi over 12 is outside of my restriction. So my answers for this equation are theta equals pi over 12. I always try to put them in order. 5 pi over 12. 17 pi over 12. Sorry, 13 would be next. And 17 pi over 12. Okay, and I'm sorry I am having some technical difficulties and can't figure out how to load Desmos with and show it on the video screen. But you should be able to plug this into your graphing calculator. And if you put in these values in your trace, okay, you should see that the y value is 1/2.